Good morning. Today we are working on chapter 6, section 3, and this is the first day of it. And it's solving systems again. So far that we've learned solving systems of equation by, somebody tell me what we've learned? We should say graphing. We've learned solving systems by substitution. And today we're going to learn solving systems by elimination. Elimination. So just another way of solving equations, which we've been working on. So solving a system, how you do it, one of the ways is you just add the two equations together. This works if you have two variables. Here we have this 5y, and here we have negative 5y. So if I add those two together, I know the y's are going to disappear, which is going to make my equation just be an x's. So that's what I'm going to do. But it has to be a point where you have one coefficient on a variable, so the number in front of the y is the same, or just opposite of each other. So if I add these two equations together exactly as they are, I'm going to say 2x plus 6x is 8x. Negative 5y minus 5y, those disappear. So I'm going to have 8x equals 17 minus 9 is 8. Sorry about that. So 8x equals 8. So I need to solve for x, and so I'm dividing both sides by x. Excuse me, by 8. Sorry about that. Sorry, and you get x equals 1. And just like before, we're not done when we get x equals 1. We have to find out what y is. So to do that, we plug it into either one of our equations. We take this x is 1 and we plug it in someplace where there's an x. So 2 times 1 plus 5y is going to equal 17. This is 2 plus 5y equals 17. So next step, hopefully somebody said subtract 2. And you get 5y equals 17 minus 2, which is 15. Divide both sides by the 5. And we get y is 3. And remember, we write our answers as ordered pairs, so we have 1, 3. And then we have to check to make sure we have the right answer. So we're going to use that 1, 3. We already used that first equation, so now I'm going to look at this one and see if it works in this equation. So does 1, 3 work here? So we have 6 times 1 minus 5 times 3. Is that negative 9? So we have 6 minus 15, and that is negative 9 equals negative 9. So our check is successful, and we are done with that problem. All right, so let's look at this next one. You guys go ahead and see if you can do this. So you are just going to try to add those two equations together. Put me on pause until you, hopefully half of you at least, are done with it. Okay, so let's quickly go over it together. If we add these two together, I looked here and look at, I have a negative 6, positive 6. So those two are going to disappear. That's great for us because I am down to just x's then. So you have 8x equals 48 minus 32. So 16. And we divide by 8. And we get x equals 2. And again, we have to plug that x in. Doesn't matter which equation we plug it in. Let's take it and plug it into this top equation. So if I plug x in there, I get 5 times 2 minus 6 times y equals negative 32. So 10 minus 6y equals negative 32. We subtract 10 from both sides, and we get negative 6y equals negative 42. Divide by negative 6. And we should get y equals positive 7. So our ordered pair is 2, 7. And we have to put it back in the other equation. So we're going to put 2, 7 into this equation. So 3 times 2 plus 6 times 7. Is that 48? 3 times 2 is 6, plus 6 times 7, which is 42. 6 plus 42 is at 48. 48 is 48. So our check is successful. All right, so if you look at this one, this time it's a little bit different. I have these x's here that have the same number, but one isn't negative and one isn't positive, so if I add them together, they're not going to disappear. So we have to do something to the equation to make it so when I add those together, something's going to disappear. And we know that if we multiply or divide something by -1, that it changes all the signs. So if I multiply this whole thing by a -1, I'm going to distribute that -1 in here. I'm going to get -1 there. Excuse me, a negative there. I'm going to get a positive here. And I'm going to get a positive here. So multiplying both sides by -1 just is going to change all of my signs. And when I do that, I get, now I can add. So 2x minus 2x, the x's are gone. 4y plus 2 more y.
Cedric has an apple. Please come to the office. Your grandmother is waiting.
Okay, so 4y plus 2y is 6y. 22 plus 8 more is 30. Again, we divide to solve. We get y equals 5. We have to plug it into one of the other equations, doesn't matter. Let's plug it into the top one. So we get 2, excuse me, that looks like a minus and it's not. So we get 2 2x plus 4 times our 5. Is that 22? 2x, excuse me, that is 22, so we have to solve and get it. 2x plus 20 equals 22. We're going to subtract 20 from both sides, and we get 2x equals 2. So x, if we divide by 2, should equal 1. So our ordered pair is 1, 5. Our last thing is taking that 1, 5 and plugging it into this equation. So we're going to, because we already used the top one, we're going to go down here. I'm going to say, and we're going to do it to the original equation, so I'm going to get rid of all my change signs. We had 2 times x, which is 1, minus 2 times y, which is 5. Is that equal to -8? 2 times 1, 2, minus 2 times 5, 10. Is that -8? Yep, -8 is -8. So our check is successful. So our answer is 1, 5, the ordered pair. You guys go ahead and try these two and put me on pause while you do that. All right, so if you're back with me now, you can see that I started by multiplying everything in the bottom by -1. So I changed all the signs, which is a legal move. As long as I do it to both sides. Now we can add them together. My x's disappear, which is nice. My y's, I have 3y equals 44 minus 29 is 15. Yeah, so 3y equals 15. If 3y is 15, y has to be 5. Not done. I have to pick one of them to put it into. Doesn't matter which one. Let's go at the top. 3x plus 7 times 5 equals 44. 3x plus 35 equals 44. Subtract 35. 3x equals 9. Divide both sides by 3, we get x equals 3. So now we have the ordered pair 3, 5. And again, I have to check it. We used the top equation to find y. So I'm going to use the bottom equation to plug them in and see if it works. So I have 3, 5. So I have 3 times 3 plus 4 times 5 is that 29. 9 plus 20 is that 29. You betcha, 29 equals 29. Success! All right, moving on to the next one. Again, this one we could solve by substitution because all we'd have to do is move that 7y over, and then we could have a substitution problem because we'd have x equals. But it says solve by using elimination. It also isn't going to be too difficult. I multiply one of the equations by a -1 because both my y's are exactly the same, -7y, and I need one to be positive, one negative. If I do that again, it changes all of the signs. So now I can add them together. I have 4x minus x, which is 3x. My y's are gone, equals 3 plus 15 is 18. Got to divide by 3. I get x equals 6. Plug it in to one of the equations or the other. If I plug it into the top equation, I get 4 times 6 minus 7 times y is that, or equals 3. So 6 times 4 is 24 minus 7y equals 3. I'm going to subtract 24. You get -7y equals -21. Divide by -7. Then you should get y equals 3. So we have the ordered pair 6, 3. Again, we need to check it. So we're going to take this bottom equation to check. So we know x is 6. So 6 minus 7 times our y, which is 3. Is that equal to -15? This is 6 minus 21. 6 minus 21 is -15, so our check is successful again. All right, so homework is a worksheet. We will see you again on Tuesday. The worksheet won't be due until, so if I give it to you on Monday, it's due on Wednesday. If you guys have questions, we're going to work some more on the same thing for the next couple of days. So feel free to ask questions on Tuesday and just get started on the worksheet though.